Okay, we'd like to use some intuitive methods here to find the derivative of sine and cosine, those functions, sine and cosine functions. So what we want to do now is look at this diagram, which is a quarter of the unit circle here. This is theta. Theta is measured in radians. So this is a unit circle. The radius is 1. So what we know is that we have that the arc length of a part of a circle is r theta, but r is 1. So this over here is going to be theta. It's r theta. R is 1. And so we increase theta infinitesimally by d theta. And so this length is also d theta. Now, when we increase theta by d theta is an infinitesimal. It's so small that it doesn't show up on the xy plane. But each point on the xy plane is contained in there is a continuum of infinitesimals. So we won't get into the theory, but we'll just move along. Now, as theta increases, sine increases. You see that? So we can draw we can draw the new positions. Okay, here's the positions here now. The new positions are that the sine is increased, but what happened to the cosine? Well, the cosine decreased. And this is sine because the hypotenuse is 1. Sine is opposite over hypotenuse. This is the cosine originally because cosine is adjacent over hypotenuse. Hypotenuse is 1. Now, over here is the change in the cosine. So that's d cosine theta. That's d cosine theta. Now, let's look at what happened to the sine. The sine increased by this much. So that's going to be d sine theta. That's d sine theta. Now, what about the length of this side? Well, it's not d cosine theta because this is negative. It's a negative change, all right? So this length is going to be minus d cosine theta. So let's look at that infinitesimal triangle. What's that you say? It's not a triangle? Yes, but see, that's what it means to be differentiable. You have, this is just talking intuitively. This is going to be a piece of the tangent line. This is not drawn to scale. It can't be seen. This increase in the sine and decrease in the cosine. So what we have here is minus d cosine is the length here, and the length of here is d sine theta. Over here we have d theta. However, this over here, this piece, this angle over here is theta. And this angle over here is pi over 2 minus theta. Well, you know it as 90 minus theta. So this is also theta. All right. So this is pi over 2 minus theta. And this is theta. So we look at this triangle here, and we get that the sine of theta is opposite over hypotenuse. And we get that the cosine of theta is adjacent over hypotenuse. Now, these infinitesimal numbers can't really be seen on the xy plane, but their ratio can. And so here we have the formulas for the derivative of the sine and the cosine. Derivative of the sine is the cosine, and the derivative of the cosine is minus the sine. So that's the name of that tune. Yeah.